Good afternoon, everybody. Phil Brown here with JitCAD Cam. As always, this week we're going to go over how to do a flywheel for the first setup inside of Fusion 360. Now, I do have to say is if you're looking for the second setup, we will be releasing that next Thursday. And the best way for you to actually get information on that is to go ahead and hit that subscribe button and turn on notifications. Now, that being said, before I actually get to programming this, the last thing is if you want to work along with me, there is a link down below to get a copy of this file so that you can actually work along and work through this process. So let's go ahead and jump into it. So I'm already in my manufacturer workspace. So the first thing I'm going to do is I'm going to create my setup. So from here, I'm going to flip my Z. I'm not really going to adjust my stock size at first because one, I don't know what my stock size is going to be on this part. I can always update that later. And because we're going to set a lot of our toolpaths to use stock settings, it's going to be very handy in the long run. So let's go ahead and get into our toolpath programming. Before I do so, I do like to actually do a section view on my part just for later purposes. So I do see my x-axis is pointed up here. So let's go ahead and do a section analysis based on that direction. Again, this will come in handy later when we start to do our outside work on our part. So from here, let's get into our turning face. So I'm going to go ahead and pick my tools here. So I'm going to go back to the default library. Let's go ahead and just grab a right-handed CNMT tool. Now, one thing I do recommend to most of you out there, you probably see me do this a lot, toggle on multiple passes. I would always have this on, and I would save this as a user default if I was on a shop floor. Now, I'm not necessarily on a shop floor 24/7, so I like to show you guys where things are and how to kick them on and off. But setting that as a default is always an insurance policy, and it will automatically update based on your stock size changes in your setup. So now that we have our facing, let's go ahead and do our profile roughing. Now, again, we're going to go from the rough front to the actual shoulder because we will be holding on to this part. So let's change our backside selection. So I'm going to go ahead and grab that flange face. And as you can see, we're now roughing to that point. I'm going to go ahead and right click on that toolpath for our roughing, and I'm going to use that to trigger everything for finishing. And the reason for that is because it's going to pass through that selected face and make my life much easier. So from here, I'm going to go ahead and now do my inside drilling. So let's go ahead and go to our drill toolpath. I don't know what size drill I need off the start, but I'm going to go ahead and highlight that hole. The idea is we're going to pre-drill it and then we're going to bore it anyways. So knowing that's 945, let's go out and find a drill bit close to size that is going to leave enough material for our boring bar to get a bite. So what I'm going to go ahead and do is I'm actually going to bore mine out to a lovely 7/8. And that 7/8 is going to be handy later, but let's go ahead and say aluminum drilling. We now need to define the face we want to drill. And this is where we're going to get our first taste of starting to use certain settings and certain changes, right? So I actually want to start at model top. Keep in mind, we do face this to model top. So this is where we're kind of tying those two together. Now I want to drill through the stock bottom. And I do want to break through the bottom, again, accounting for that tip automatically. And I would like to give it an additional distance. Now, the idea is we are going to flip this over in a setup too, not to sales pitch you again on getting your notifications for next Thursday. But this makes it much easier where I don't have to drill the backside, right? We're just allowed on a very, very thin part, so to say, to be able to drill through it all from one side. Now, on my cycle tab, I am actually going to go through a breakthrough. Now, the breakthrough is going to allow me the ability to actually slow down my feed rate as we punch through the backside of this part. Keep in mind, when you set this breakthrough distance, it is not accounting for tip. It's actually just a hard number. You can create an expression to do so. However, this is where we're going to start to slow down. So at 0.875 from my lowest point is when that drill bit's going to slow down for that breakthrough. So now that we've pre-drilled that out, let's go ahead and start to do our boring operation. I'm going to go up to the top and I'm going to say turning profile rough. We're going to go ahead and select our tool. So from here, again, I'm going to go back to the default library and I am going to pick my CNMT. Actually, not CNMT. I apologize. We're actually going to go for our ID boring tool here. Now, a lot of times I like to leave everything as the default and just see what Fusion gives me. However, for the sake of this video and speeding things up, I'm going to start by changing my radii because I do know I pre-drilled this hole. Now, if anybody from Autodesk is watching this video, it would be very, very nice is if there was an option to say drill here and reference that drill that we pre-drilled, right? So now I'm going to go ahead and manually type this in. And by the way, guys, if there is a way to do this and you know how, or if Autodesk wants to chime in and leave a comment down below or shoot me an email directly, I would be happy and ecstatic about that to also add it to my video collection. So another thing I am going to change is my clearance to inner radius, and I'm going to set this at 40. And again, if I was doing this all day, every day, guys, I would definitely make these my user default. This means that we're always referencing whatever this is set to as an inner radius, and that keeps us from getting that error message, that tool crosses center line. It also keeps you away from always going back to center. So I'm going to go ahead and hit OK, and we're going to see what we get. So we actually get quite a bit here. We're actually getting some undercutting here on the backside. So let's go ahead and clean that up real quick. So we're going to go ahead and go back into that toolpath. I'm going to go ahead and not allow radial and axial grooving. Now, as you're seeing, we're coming straight across the backside of this part. Now, one thing I may also want to do here is I'm going to go ahead and I'm going to actually bore this again. And what I want to do is I want to go all the way to the stock back. And then I would like to go past that just a hair. So I could either do an offset or a tangential extension. Now, a tangential extension is much more handy from a model edge. An offset is much more handy when trying to, again, break through that entire area. So my mistake here, again, that needs to be a negative. And if you were looking at that line, it went to the wrong side of my profile. But we are now boring out a rough path on the inside of this, and then we are working our way outward. So if we go ahead and simulate this real quick, I do know we are going to get collisions. And let's go ahead and turn on that stop on collision. I always, when it comes to boring, guys, I always like to simulate my boring path right out the start, because a tool you think could fit may not actually fit, right? So we may need to go to a smaller offset boring bar to be able to do something like this. So again, we're being able to see this in real time. And this is probably the best thing about Fusion, is the ability to do offline programming like this, which means we can actually speed up what is going to happen at the machine and the downtime of setup and proofing out programs. So what I'm going to do is I'm going to go ahead and quickly edit this tool. If you guys haven't seen the tool dialog area, I'm going to have some video content coming out on this later. What we're really looking for is this cutting width. Now, keep in mind, this cutting width is coming from a center line dimension, right? So it's not the full width of the head. It's from center line to tip of tool. So what I'm going to do is we're actually going to release this down. And again, for this video concept, guys, a lot of this stuff is built around giving you guys the ability to use the cam cycles to do this, more than it is the exact and precise, at the end of the day, increments that you need, right? As you've noticed, I haven't adjusted my step over, things of that nature. Those are all tool parameters that you're going to change. So again, based on the fact that we have now simulated that with a different offsetted boring bar, we have made this with no problems, no collisions, and no issues. So I'm very happy with this roughing strategy. So again, we're just going to go from a rough straight to a finish and see what we get right out the start. So as you're going to see now, is we are coming in and we are doing that finishing strategy. I am getting an error message here. Now the lead out has been modified because it's gouging the stock. This is a common thing that we see. So what I'm going to go ahead and do is I'm going to go all the way over to my linking tab. And now what I can do is I could say a radial extension, which is going to bring that tool off my part, or I can allow the lead to cut stock. Now, if I turn on allow lead to cut stock, we do have to be cautious about how long that lead out is, but my error has gone away. And again, whenever we get to boring, guys, I always like to simulate to make sure. That was a very quick simulation on your end, but as you can see, I have no collisions in my timeline at the bottom. So that is working out perfect for me. So now that we've cleaned out that inside area as best we can, we still need to do more or less some face grooving and things of that nature. Now, the way you're going to approach this, and the way I have found that works really, really well, is I am going to base this not off of an actual grooving profile. I'm going to do this with a turning profile rough, and you'll see why here. So I'm going to go out and I'm going to grab my tool. And in the case of this tool here is I'm going to go ahead and pick a OD grooving tool. And the tool I'm looking for is kind of like a lollipop tool. Again, I hope Autodesk watches these videos. If you guys are watching these videos, the control to move this should be same as my user default in my workspace. It would make my life a million times easier versus having to switch back and forth and use shift key toggle. But again, let's go ahead and grab that lollipop cutter. We are working on this part, so I'm going to go ahead and hit OK as its standard settings because I don't know quite how it's going to react, right? So we did say just use a grooving tool, however, use it as adaptive clearing. And as you can see now, we're doing our OD work, right? Well, let's start by switching from OD work to ID work, right? So again, as we're going to go from outside to inside, I'm going to hit OK. And now we are getting a path, but my tool is completely wrong in its orientation, right? So let's fix our tool. So again, as I'm going to right click, edit tool, I need this tool to actually be mounted to the left. And again, we're going to go ahead and regenerate to see what we get. So just by reorientating that tool, we actually got a lot of what we wanted. However, we're still missing a good portion of items here in this toolpath. And the reason why we're missing some of this stuff is because the good old-fashioned radial and axial grooving is coming back to haunt us. So if you didn't know right now, so currently by default, and again, this is up to you guys what you set it to. If I can get my mouse in the right spot to open this window up, man, I'm having some problems today. There we go. Now, let's go ahead and say I want to allow both radial and axial. And what that is going to now do is you can see is we're now getting in that cavity. However, we're also getting in a bunch of spots where we don't want to be, right? So again, let's go ahead and adjust something. And what we're going to adjust is we're going to start to use rest machining. And what rest machining now is going to do is limit us to specifically one little area where there's still material. Now, with that being said, though, I am getting this lovely error, and this is an error that I talked about earlier, right? Tool path crosses rotary axis. I can't tell you how many times I have gotten people questioning that. So how you fix that, again, is in your radii menu, you have a clearance. We always base that off our inner radius. I shouldn't say always. What I recommend is basing it off inner radius and setting it to 40. And now, as you're going to see, is it didn't quite fix our issue. And the reason why it didn't fix our issue is because it's still thinking in the concept that we're working from a stock inside diameter, right? So if we were to change this to, say, selection and pick, maybe that bore, what you're going to notice is that error is now going to go away. But I'm going to show you guys another way. So another way you can do this is you can actually go in and you can say, I want to use first toolpath point, last toolpath point. And what that would normally do is that would normally align you to that pocket. But again, because of all of the safeties inside of Fusion, that issue is still revolving around the fact that it thinks the first point, we are using an inside toolpath, so it thinks boring, right, is still working from the stock inside diameter. So in this case, you're going to still go ahead, do a selected diameter, and this is going to help you to, again, first point, last point, start down inside your part. So I'm going to go ahead and toggle off first point, last point here. And the reason for this is we're just going to go back to the default settings of Safe Z. As you can see, it really didn't affect anything on this toolpath. However, that first point is super handy with a lot of other things as you get to working in Fusion. So again, we did a roughing path. We want to do a finishing path. Let's do our derive. We're going to go ahead and do our derive now. Again, all of our geometry and our selections all come through basically automatically. So we're going to go ahead and hit OK. And just like that, we are now getting our finishing path. Now, based on our finishing path, and this is up to you guys how you set things and the different ways you're thinking about doing it, is you do have that ability to adjust and make changes. Again, your scenario is always going to be different. As I like to tell some people, it's kind of like riding a bike, right? Once you ride a bike, you can ride any bike. And that's a big thing to a lot of people is we're just trying to teach you how to ride a bike. Now, whether or not you have a mountain bike, a speed bike, a motorcycle, the concepts are still the same. It's the little things that are going to change. Now, again, we're going to go ahead and leave this as is. I like that finishing path. It works very well for what we're doing. If you guys want a little different example of first point, last point, again, you could go ahead and play around with this here, where you save first point, last point of toolpath. And again, because of the way our clearances are working, it's always coming back to that clearance height versus starting in our part at those locations. So you do have to adjust that as needed. So as always, let's go ahead and run this through a simulation real quick. Again, we are getting some collisions, and some of those collisions are coming from the fact that the way that tool is approaching that material. And that's nothing too big to worry about. I can, of course, adjust my settings, my step over, my step down, things of that nature. But for the sake of this, let's go ahead and turn off that stop on collision. And we're going to go ahead and slow down our simulation because we are way too fast there. But as you can see, we went in, we came back out, and we've now cleaned out the inside of that board. If you guys wanted to, by all means, instead of using that like straight on roughing approach as you see here, there is the ability to now try out the actual adaptive kind of roughing strategy. And I would recommend giving it a go because it can make a very dramatic difference on how you are getting these parts roughed out and cleaned out at the end of the day. So because of rest machining and everything, I'm going to go ahead and drag this up and regenerate it up here. But now what you're seeing is more of an adaptive or an archy kind of approach, but we're also working inside and outside versus front to back, right? So again, let's delete that out of there so that we're not affecting anything that we've accomplished so far. But I think a lot of you are here for the meat and potatoes, which is going to be, you know, kind of this drilling side of things, as well as being able to actually machine the outside areas. So what I'm going to do now is I'm going to go ahead and I'm going to turn off my analyze. I am going to drill some of these holes. I'm not going to drill all of them because I don't want to bore you guys with it. So let's go ahead and select our spot drill. So again, I'm going to pull something from my crib. And if you guys haven't seen this before, super neat thing in Fusion, you could just pick your hole faces that you want to drill. You could say, go find the same size diameter. And now we are no longer going to a hole bottom here. We are actually going to go in and we are going to say is I want to go to a chamfer width. And let's say, for example, these are actually going to be probably tapped holes. So I may split them up into 2 separate cycles. But as you're seeing is I can, based on the defined areas of my tool, chamfer this when I spot drill it for drilling, right? So again, now we go back, we say drill. I need a 315 drill. So let's go ahead and go grab a 315 drill. So I'm going to go ahead and scroll down and we have a 3125, 316. Again, based on if that's a tapped hole or not, you guys are going to define that accordingly, of course. Let's go ahead and select our drill. We're going to go ahead and pick our geometry, same size hole. These are blind holes. So we do want to go drill tip through bottom if we need to get down to that shoulder height. And in this case, we're not actually going to give it breakthrough because we're not going all the way through our part, right? If you were to do pecking or something of that nature, you could go ahead and set your chip breaking things here. And with that being said, we've now drilled out those holes. If I wanted to go back and tap those holes, by all means, again, it's just a drilling operation, picking a tap, picking your surface over and over. You could even derive this guy into the next one. But now let's get into the actual end mill kind of things that we're going to do. Again, we need some live tooling on this because we need to rough out the areas between all these lugs. So what I'm going to do is I'm actually going to go to the milling tab and I'm going to go for an adaptive clearing. So I am going to select an end mill and I'm a big fan of 1/2 inch end mills if you guys didn't know. Obviously on the lathe, you might have to do something a little more gentle based on what you're going for. But we're going to go ahead and we're going to rough this out based with rust machining because we've done a lot of stuff already to this. And now based on our heights, I do know right off the start, I don't want to go lower than this flat. So I am going to add this in here. And the reason for that is if I don't, it's actually going to try to machine the shoulder up here. And that would be hitting our jaws on our machine. So think of it as like a precaution right there to be able to set that automatically in real time. So as you can see, this is one thing that I absolutely love with Fusion is the rust machining is on par and does a really, really good job of finding where and what needs to be roughed out, right? So again, is if we're simulating this, you can see the blue versus green on my settings. And just like that, it is now recognizing that it needs to go in and it needs to rough out all of these areas. So from that, we do have that ability now is we can go in and start our finishing strategies. So what I'm going to do from here is we're going to go ahead and do a 2D contour. And now, again, I'm going to keep that same end mill. Let's go ahead and go to a finishing path. Now, I'm using 2D contour, and the main reason for that is because I have a wear setting in here. But as you're going to see here in a second is I can pick all my profiles very quick and efficient. So for the sake of this actual part, I'm actually picking these upper chains. And the reason why I'm picking the upper chain is if I try to pick this lower chain and make it a closed chain, it's got to jump up and over here because there is no line on this back face, right? That's a perfect cylinder there. Now, if I wanted to, again, is based on machining time and knowing what's already machined, I could actually reduce this even further and say I only want to machine, this little area here, and then the same thing on the other side, but you're going to see that I'm going to start to cause a lot of selection on my part file. So we're going to do this a couple of different ways, but see how I have my upper ones done and then I have the lower one here. It's not going to make a big difference because we are going to set them all to a selected face, and that's the bottom of the pocket here. So as you can see, again, this is already a machine face. This is already a machine face. This allows me to go in and just machine two sides. Again, on these other two, I did pick the upper edge, and we are walking all the way around them. To each their own. I don't think there's one way that's right or wrong. Now, keep in mind, I do have a repeat here, or a pattern, so to say, where it's 3 times the same situation. So what I'm actually going to do is I'm going to go up to setup. I'm going to say new pattern. This is going to be a circular pattern. I'm going to pick my axis of rotation, and then I'm going to set the number of times I want this. So again, as we're going to do this 3 times in a 360-degree circle. Now, I do want to actually put the drilling and everything all inside of that same, so to say, organized folder, which is also going to cause my adaptive clearing to need to be updated. But as you can see, based on the pattern, we are now drilling and tapping, and I should say, you should be drilling, tapping, and spot drilling all that info. Now, we do have to be careful with this, though, because when we set the geometry of this toolpath, we used select same size diameter, right? Well, if you're going to use a pattern, select same size diameter is going to throw that off at the end of the day. So I want you guys to be cautious of that, because you think about it, if I do 3 times this, it's going to take this exact profile and pattern it 3 times. So I'm going to be double drilling holes, which is going to cause a lot of problems versus only doing the little section that I pattern, right? So at this point, we've now roughed out, we've now finished out the outside of everything, and from there, we've now patterned our drilling cycle. This is going to drive me nuts. I have to fix this real quick, guys. So again, we're just going to go ahead and pick our individual faces here. Bada bing, bada boom. And then I do want to get that spot drill on those other ones. So again, this is my spot drill. We want to go to a chamfer width. Yes. And then lastly, I want to add in this whole face here. There we go. So let's go ahead and simulate this out now, right? So let's go from the top. We're going to go ahead and hit simulate. And actually, we know everything is good to a certain point. So let's go back down here. We're going to simulate just the drilling cycles, right? Now, again, with Fusion 360, it's always great because it does show you what is and isn't missing, or what could be an issue, or what couldn't be a problem, right? Now, if I was, not having the ability to simulate this, I would get to the machine and run this part, and then I would probably go, oh shit, we forgot to do some areas, right? And that can be extremely frustrating. Now, again, because of Fusion and the ability to offline program this, we are seeing this stuff in real time as to what can and cannot be done, or what still needs to be done, right? So from here, we can go ahead and clean up that face. There's a lot of different ways to do that specific area. Now, it's up to everybody and their own as to which way you choose. However, if I go in and I try to do something like a horizontal toolpath, I don't have rest machining. I do, however, have boundaries, which this is where you're going to run into some problems, right? So as you're going to see is I'm actually not going to use that edge. I'm going to use this outer edge. And now from that outer edge, if I say inner edge, and we're going to say tool center, for example, what's going to happen is we're actually going to go in and do all kinds of faces that we don't need. The same kind of rule applies is if we go back and we say now 3D, let's try a flat toolpath. Again, I do have rest machining here, which is extremely valuable. However, that flat toolpath, once again, is going to recognize certain things that can cause problems and issues, right? So we'll give that a second to calculate. You guys will see is that rest machining, although it is very, very handy, it's still going in and recognizing a lot of faces and a lot of features I don't want. I know the area I want is between an inside edge and an outside edge. So what we can do here is we could actually go back to design, drop a sketch, and what that sketch is going to allow us to do is to very quickly create our own boundary, right? So if we go back, again, I'm just going to do this with the flat strategy. We're going to give it a selected boundary. Again, inside edge. Now I'm using that sketched edge here. And I'm going to go ahead and hit OK. Now what's going to happen is it's now going to recognize the fact that we're trying to define it to stay only in one little specific area. However, again, because we are using a boundary, right? It's thinking tool inside boundary, not on center or tool outside of boundary. So again, you're going to have to play around with this to what's going to work best for you at the end of the day. But as you're going to see just by saying tool center on boundary now, I'm going to get a night and day different result once again to be able to go in and clean out those flat areas. And of course, if I go to outside as a starting point, it will start even further out. Again, the nice thing here in Fusion is as you're seeing is we're now being able to clean up those areas as needed. So another strategy that I think a lot of people overlook when it comes to this is the ability to actually go in and use like a pocket clearing strategy as well based on that defined information. So again, we could say selected boundaries here and here. I'm also going to add a stock boundary. And the reason for that is because if I come over here to the linking tab, I could actually say plunge outside of stock. Now, everybody has their own way of doing this. I don't think there's necessarily a right or wrong. Rust machining is getting me pretty good here, guys. So let's go ahead and kick off rust machining. But you are going to be fighting things like step downs and other things outside of that. Again, we're going to go ahead and go back here one more time. We want tool outside of boundary. Let's see if that fixes our plunging. That was interesting. I saw a little question mark for the first time ever. But as you're seeing is the lead parameters would cause a problem. So I've made the cardinal rule that you should not do is go in and select a bunch of stuff in one shot with the hopes that it works. Let's restart this here real quick. We're going to go pocket clearing. I'm actually not going to give it a bounding shape of any. We're going to go ahead and hit OK. Now, I do know rust machining is on, guys, so I'm expecting that we basically get nothing on this first time through, which is partially the case. So let's go ahead and reorder a few things here. So we're going to go ahead and drag that up. I'm going to go ahead and regenerate that one more time. Before, when I was talking to you all about that adaptive machining the outside of the part, the reason why we selected a floor was exactly that, right? So let's go in and let's change our Z heights, not the whole model. And what you're seeing now is we have a sketch in our way. Let's go ahead and get that sketch turned off so we can pick the face. And then we are getting a ton of step down, so I'm going to go ahead and bump my step down up to 1 inch. As you can see, this is much closer to what I wanted, but we're still making multiple step downs. Again, the way Fusion is working in the 3D world, guys, is because it's always thinking of a maximum step down, not what is your step down, right? So if I only wanted to do the floors specifically with this toolpath, I would actually have to change my top height also. And I would have to say that, you know, it's 5 thou above and use that as my reference when it comes to trying to machine those faces. Keep in mind here, I also have the dilemma of the fact that you can't leave 5 thou on a face that has 20. Let's go ahead and get rid of axial cleanup. And as you're seeing now, we're getting a lot more of what I was kind of talking about. This is now using a pocket clearing toolpath to clean up the floors. None of these are right. None of these are necessarily wrong. Again, every scenario has a different way to do it, right, guys? And that's the best thing about this is, you know, it's not what you know, because we don't know it all. I don't know it all. You don't know it all. It's a big part of the game here. Fusion updates every 2 weeks, and I still don't know, I think, the things in the last update. However, you guys do know yours truly over here at JitCAD and I'm here for you guys to help you in any way to learn this content, to understand how toolpaths work, and even to see in better ways we can improve your current workflow. That said, if you guys want more information on JitCAD and our services, feel free to reach out on the link below. And as always, have a great rest of your day.